All right, on number 13, we are multiplying these two cube roots together. Note that neither one has a coefficient out front, so we don't have to worry about that part. All we need to worry about here is the stuff underneath each of these radicals. So we can multiply everything underneath the radicals together. So we have a -3 under the first radical times a 36 under the second one. -3 times 36 is -108. Moving on, we have an a to the 7th times a to the 6th. And this is where a lot of people have had questions. Keep in mind, when multiplying powers with the same base, we want to add those exponents. So we have a 7 and a 6. We want to add those two numbers together. So a to the 7th times a to the 6th is going to be a to the 13th. And last but not least, we have b to the 4th times b squared. Same thing, we're going to add those two exponents together. 4 plus 2 will give us a 6. So now we have everything underneath one radical, but we need to simplify. The problem is that we have a perfect square factor for all three of these. So we can go through and simplify that 108. We'll start with that. Because this is a cube root, we are looking for perfect cubes. So usually we're looking for perfect squares, numbers like 25, 36. Now we're looking for perfect cubes. So I recommend having your cheat sheet out with that big list. In the case of 108, the biggest perfect cube is 27. 27 times 4 gets you back to 108. So we have our two factors here for 108. Again, the reason I'm picking 27 is because 27 is a perfect cube. We also have this negative to deal with. So because we can take the cube root of a negative number, I'm actually going to bring that negative out with the 27. The reason why is because I can take the cube root of -27. Cube root of -27 is just -3. So -3 is going to come out of that radical. The 4, on the other hand, the cube root of 4 is not a nice number, so there's nothing we can do to further simplify that. The cube root of 4 is still just cube root of 4, so that 4 stays behind. So when you have a nice perfect cube, that comes out of the radical, but when you have something like this 4 that doesn't have a perfect cubic factor, then that's going to stay behind. Looking at our two variable pieces here, now we're playing that middle school game. How many times does 3 go into 13? Well, 3 times 4 gets us 12. 3 times 5 gets us 15. 15 is too big. So 3 is going to go into 13 4 times. That's going to come out of the radical. So when you're playing with variables, it's very much that game. How many times does our index go into that exponent? So 4 of them come out. The problem is 3 doesn't go into 13 evenly, so we're going to have an a left behind. Again, we have one a left behind because there's one left behind in the middle school game. 3 goes into 13 4 times, but 3 times 4 is 12, not 13. So there's the 1 left behind. 12 plus 1 gets us the 13. Had that have been a 14, it'd be a squared left behind. There'd be 2 left over. So that takes care of our a cubed. Last but not least, we need to deal with this b factor. So right now we have b to the 6th. We're taking the cube root. 3 goes into 6 2 times with none left over because 3 times 2 is exactly 6. So we don't have to worry about any left behinds there. Right now my work does look a little bit messy. Things are a little scrunched and I've got this radical that's really large. So we can rewrite that and make it something nice and clean. -3 times a to the 4th, b squared, all times the cube root of 4a.